Hello, in this lecture we will answer on two questions. In the first question, we will find out the side length of square ABCD, and in the second question, we will find out the length of line segment AD that is equal to x. So we start with the first question. In the drawing, we have square ABCD, and we know that line segment DE, the short line segment DE equals to 1 unit, and the radius of this circle is equal to 2 units. So here we define the radius of this circle as O, the center of this circle as point O. We will define the point of tendency of tangent AD with this circle as point M, and we will join the points O and M together by a straight line. Here O is the center of this circle, and point M is the point on the circle itself. This is exactly the definition of a radius. So line segment OM is the radius of this circle. We define the radius of this circle as R, and it is given as the question that R equals to 2 units. So here we have the radius of this circle that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the point of tendency of tangent AB with this circle as L. We join points O and L together by a straight line. Here, line segment OL is the radius of this circle because of the fact that it starts from the center of the circle and ends at point L, that is the point of the circle itself. So OL equals to R, that is equal to 2 units according to what is given as the question. So here we have the radius OL, it is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO. It means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay? We know that all the angles inside the square are right angles, so in square ABCD all of its angles are right angles, that is to say angle DAB equals to 90 degrees. So actually here in quadrilateral MOAL, we have 1, 2, 3 right angles. So I write it down. In quadrilateral MOAL, we have three right angles. The sum of three right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MOL. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle MOL, is equal to 360 degrees minus 270 degrees. It is 90 degrees. So we found out that the missing angle is a right angle. It is equal to 90 degrees. So we can write here that in the drawing that angle MOL is a right angle. So actually, in quadrilateral MOAN, we have four right angles. In quadrilateral, in this quadrilateral MOAN, we have four right angles. Any quadrilateral that has four right angles must be at least a rectangle. So we relate to quadrilateral MOAN as a rectangle, because it has four right angles, okay? We know that the opposite sides of a rectangle are equal to each other. So in a rectangle MOAN, MO must be equal to AL. MO must be equal to AL. But MO equals to 2 units. It is the radius of the circle. So we can write here that MO equals to 2 units. And from this equation, 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. AL is also equals to 2 units. So here, AL equals to 2 units. So, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that OL equals to MA. OL equals to MA. Okay. But OL equals to 2 units. This is the radius of the circle. So we can write here that OL equals to 2. And from this equation, 2 equals to OL equals to MA. We will derive that MA is also equals to 2 units. MA equals to 2 units. Here, we can write that MA equals to 2 units. So, we actually found out that quadrilateral MOAN is a square, and not a rectangle but a square. Quadrilateral MOAN is a square. Okay. In the next step, we will do a construction actually here I will present to you a new rule that is actually rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Okay, so we'll focus on point E, the common external point E. From the common external point E, we have two tangents to this circle. The first tangent is tangent EM. And the second tangent, actually, we will define the point of tangency of line segment EB with this circle as Z. So the second tangent from point E is Z. And according to rule number 2, the lengths of those two tangents are equal to each other, that is to say EM equals to EZ. According to rule number 2. What is the length of line segment EM or tangent EM? For the drawing, it is very easy to see that EM equals to dA minus dE minus MA. dA minus dE minus MA. I'll repeat again. EM equals to dA minus minus dE minus MA. Okay, so we will define the side length of square ABCD as X. That is to say, dA is equal to AB, and it is equal to BC, and it is equal to CD, and according to our definition, it is equal to X. I'll repeat again. The side length of square ABCD is equal to X. That is to say, dA equals to AB equals to BC equals to CD equals to X. Now, what is the length of line segment EM? According to this equation, we get that EM equals to dA, that is X according to our definition, minus dE, dE equals to 1 unit according to what is given us in the question, minus MA, MA equals to 2 units according to what we have already found out. So in conclusion, EM equals to X minus 3. EM equals to X minus 3. So we can write here that EM, in the drawing, that EM equals to X minus 3. So actually, according to rule number 2, we've already found out that EM equals to EZ. But according to what we just right now found out, we found out that EM equals also to X minus 3. So here we can write down that EM equals to X minus 3. And from this equation, X minus 3 equals to EM equals to EZ. We will derive that EZ is also equals to X minus 3. EZ equals to X minus 3. Okay. EZ equals to X minus 3. Here Ez equals to x minus 3. In the next step we will focus on the common exam point, point B. Actually, from the common exam point, point B, we have two tangents to this circle. The first tangent is tangent BL, and the second tangent is tangent BZ. And according to rule number 2, the lengths of those two tangents are equal to each other. So here, actually, BL equals to BZ. According to rule number 2, what is the length of line segment BL? BL, it is very easy to see from the drawing that the length of line segment BL it is equal to AB minus AL. Again, AB minus AL equals to LB. AB minus AL. AB minus AL. But here, according to our definition, AB it is actually equals to x. Here AB equals to x according to our definition. AB equals to x. So BL equals to AB, that is x according to our definition, minus AL, that we have already found out that is 2. So in conclusion, we actually found out that BL equals to x minus 2. BL equals to x minus 2, so we can write here that BL equals to x minus 2. So actually, according to rule number 2, we found out that BL equals to BZ. And we just right now found out that BL is also equals to x minus 2. So from this equation, x minus 2 equals to BL equals to BZ, we will derive that BZ is also equals to x minus 2. BZ equals to x minus 2. Here, BZ is also equals to x minus 2. What is the length of line segment AE? Here, from the drawing, it is very easy to see that the length of line segment AE equals to DA minus DE. DA minus DE equals to EA. Okay. EA equals to DA minus DE. So EA equals to DA, that is x according to our definition, minus DE, that is equal to 1 according to what has been given us in the question. So in conclusion, we found out that A equals to x minus 1. In the next step, we'll copy the right triangle, triangle AEB in a new page, and we will implement the Pythagoras theorem on the right triangle, the right big triangle, triangle AEB. So I'll copy the right triangle AEB in this page. We have already found out that side EA equals 2x minus 1, AB equals 2x according to our definition, and the hypotenuse EB equals to x minus 3 plus x minus 2. So the hypotenuse EB equals to x minus 3 plus x minus 2. That is to say, it is equal to x plus x is 2x, and minus 3 plus minus 2 is minus 5. So in conclusion, I found out that the hypotenuse EB equals to 2x minus 5 units. Now we will implement the Pythagoras theorem in the right triangle EAB. So by PT is the abbreviation for Pythagoras theorem. And we get that according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is EB, so the square of the hypotenuse is EB squared, and it must be equal to EA squared plus AB squared. I'll repeat again, according to the Pythagoras theorem, on the right triangle, triangle EAB, EB squared equals to EA squared to EA squared plus AB squared. So here EB equals to, the hypotenuse EB equals to 2x minus 5, so EB squared equals to 2x minus 5 squared. And it is equal to EA squared, EA equals to x minus 1, so EA squared equals to x minus 1 squared plus AB squared. AB equals to x, so AB squared equals to x squared. So in conclusion, I found out that 2x minus 5 squared equals to x minus 1 squared plus x squared. So here we will open the brackets on both sides of equation number 1 according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. So we get that 2x minus 5 squared equals to 2x squared, that is actually 4x squared, plus 5 squared, that is 25, minus 2 times 2x is 4x, minus 5, minus 4x minus 5 is minus 20x. That is equal to x minus 1 square, x minus 1 square equals to x square, plus 1 square, that is 1, minus 2x, plus x square, This side of equation number 1 we have x squared plus x squared is 2x squared minus 2x plus 1. That is equal to, in this side of equation number 1 we have 4x squared minus 20x plus 25. So we subtract 2x squared from this equation, equation number 1. So 2x squared minus 2x squared is 0. 4x squared minus 2x squared is 2x squared. And here we have, in the side of the equation, minus 20x. And the other side we have minus 2x. So we will add 2x to this equation, equation number 1. 2x minus 2x is 0, and minus 20x plus 2x is minus 18x. And here we have 1 on this side of the equation, and we have 25 on the other side of the equation, so we'll subtract 1 from this equation, equation number 1, and we will get that 25 minus 1 is 24, that is equal to 0. Here we will divide this equation, equation number 1 by 2, and we get that according to equation number 1, x squared over 2 is x squared, minus 18x over 2 is minus 9x, and 24 over 2 is 12. 0 over 2 is 0. So in conclusion, we got the quadratic equation that x squared minus 9x plus 12 equals to 0. The coefficient A here is 1, the coefficient B is equal to minus 9, and the coefficient C equals to 12. And the general formula to solve out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here a, b, and c are the coefficients of the general quadratic equation, and x is the variable that we are looking for. So we put the data inside the formula, and we find out the value of the values of x. So here x equals to minus b equals to minus 9, so minus b is minus 9, that is 9, plus minus square root of b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, times c is 12, over 2a. A is 1, so 2a is 2 times 1, that is 2. So here x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 48 over 2. So here x equals to 9 plus minus 81 minus 48 is 33, so inside the root we left only 33 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2 is 1.62. So according to the first solution, x equals to 1.62 units, and you should remember that x is the side length of square ABCD. So according to the first solution, one side length of square ABCD, this square equals to 1.62 units. So here side AB equals to x. So according to the first solution, AB that is equal to x, it is equal to 1.62 units. AB that is equal to x equals to 1.62 units. But here AN itself is equal to 2 units. So, and ABE that is equal to x, it is absolutely greater than AL. Therefore, AB that is equal to x must be greater than AL. So if x must be greater than AL, it means that x must be greater than 2. So x must be greater than 2. X must be greater than 2 units. And x that is equal to 1.62 units, it is less than 2 units. Therefore, this solution is incorrect solution, so we cancel the solution, and we have to live with the second solution for x, that x equals to 9 plus square root of 33 over 2 units. That is actually about 7.37 units. So actually the answer to the question is that the side length of square ABCD equals to 7.37 units, or we can represent it as 9 plus square root of 33 over 2 units. AB equals to BC equals to CD equals to AD equals to X, that is equal to 7.37 units. So we finished with the first method, with the first question. In the next step, I will present to you the second question, and we'll solve the second question in two different methods. We'll start with the first method. So in the drawing we have triangle ABC. We know that side BD equals to 2 units, AB equals to A, AC equals to 2A, angle BAD equals to 60 degrees, angle DAC also equals to 60 degrees, and we want to find out the length of AD that is equal to X. Okay, so first of all, I present to you the angle bisector theorem. According to angle bisector theorem, here AD is the angle bisector of angle BAC. Why? Because line segment AD bisects angle BAC into 2 halves. Each half equals to 60 degrees. So AD is the angle bisector in triangle ABC. So what is the angle bisector theorem? The angle bisector theorem is true in any triangle so if we have triangle ABC. That could be any triangle. This is triangle ABC. And AD is the angle bisector of triangle ABC. Why? Because it bisects angle BAC into two halves. Each half equals to theta. So write down that AD is the angle bisector here. And according to angle bisector theorem, we get that if we have triangle ABC, that could be any triangle, and in triangle ABC we have the angle bisector AD, then the following formula is true, that AB over AC equals to BD over DC. Repeat again, here AB over AC equals to BD over DC. So actually, as I already mentioned, we can implement the angle bisector theorem in triangle ABC, because in triangle ABC we have the angle bisector AD. Okay? So in triangle ABC, AD is angle bisector. Therefore, we can implement the angle bisector theorem in this triangle, triangle ABC. According to angle bisector theorem, we get that AB over AC equals to BD over DC. I repeat again, in our triangle ABC, because of the fact that AD is angle bisector, we can implement the angle bisector theorem, and according to angle bisector theorem, we get that AB over AC equals to BD over DC. So here, according to what is given us in the question, here AB equals to A, so we substitute AB by A. AC equals to 2A, we'll substitute AC by 2A. And it is equal to BD. BD equals to 2 units, so we'll substitute BD by 2 over DC. DC is the missing line segment, so we'll leave it as it is. And we'll get that according to equation number 2. A over 2A equals to 2 over DC. So here A will get cancelled. A over A is 1, so A will get cancelled. And we left here with 1 half, that is equal to 2 over DC. Here we will cross multiply this equation, equation number 1, and we get that according to equation number 1, DC equals to 2 times 2. That is to say, DC equals to 4 units. Okay, DC equals to 4 units. So we can write down here that DC equals to 4 units. In the next step, we do a construction. We will extend side CA of triangle ABC by a straight line. And then from point B, we will raise perpendicular to the extended CA. So here, actually, this angle is a right angle, according to our construction. Okay, I repeat again. This is the right angle according to our construction. We define the touching point of the extended CA with the perpendicular from point B as E. So angle AB is equals to 90 degrees according to our construction. And we focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB. Cosine 60 degrees. Before that, here we extended the straight line CA by a straight line and created line segment CE. When CA is absolutely a straight line because it is one side of triangle ABC. And we extended the straight line CA by a straight line and created in this way the line segment EC. When we extend the straight line by straight line, the result must be a straight line. So you can write down that EC is a straight line. EC is a straight line. Okay, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the lower side of the straight line EC at point A, then here the sum of the angles must be equal to 180 degrees. Okay, so we focus on the lower side of the straight line EC at point A, and here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have here at point A, the lower side of EC? We have 60 degrees plus 60 degrees plus angle EAB, this angle. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. Here 60 degrees plus 60 degrees is 120 degrees plus angle EAB. In total, they must be equal to 180 degrees. Here we subtract 120 degrees from this equation, and we get that the missing angle, angle EAB, is equal to 180 degrees minus 120 degrees, it is equal to 60 degrees. Okay, so angle EAB equals to 60 degrees. In the next step, we'll focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB. Cosine 60 degrees equals to EA over BA. fitting in the right green triangle, triangle EAB. Cosine 60 degrees equals to EA over BA. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and it is equal to EA over BA. Here, BA equals to A according to what is given us the question, so we substitute BA by A. Now here, we got that 1/2 equals to EA over A. We multiply this equation by A, and we get that EA equals to A over 2. EA equals to A over 2. So we can write here that EA equals to A over 2. We continue to focus on the right triangle EAB. On the right triangle, triangle EAB, we know that sine of 60 degrees equals to EB minus EA. Sine of 60 degrees in the right triangle EAB equals to EB over EA. We know that sine of 60 degrees equals to square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, and it is equal to EB over EA. EA equals to A, so we substitute EB, EA by A. So we found out that square root of 3 over 2 equals to EB over A. We'll multiply this equation by A, and we'll get that EB equals to A times square root of 3 over 2 units. Okay, here we can write down that EB equals to A times square root of 3 over 2 units. Okay, in the next step we will implement the Pythagoras theorem on the right big triangle, triangle EBC. So I'll copy the right triangle EBC in the new page, and we will implement the Pythagoras theorem on the right triangle EBC. Okay. Okay. So this is the right triangle EBC that I copied from the original drawing. Here the length of side EC equals to 2A plus A over 2. 2A plus A over 2 is 2.5A. 2.5a is 5 over 2a. We've already found out that side EB equals to square root of 3 over 2 times a. And the hypotenuse BC equals to 2 plus 4, that is 6. So now we will implement the Pythagoras theorem on the right triangle EBC. According to the Pythagoras theorem, PT is abbreviation for Pythagoras theorem. Here, this will be equation number 2. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, so the square of the hypotenuse is BC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to EB squared plus EC squared. Okay. So BC equals to 6 units, so BC squared is 6 squared, that is 36. And it is equal to EB squared. EB equals to square root of 3 over 2 times A. So EB squared is square root of 3 over 2 times A squared plus EC squared. EC equals to 5 over 2 times A. So EC squared is 5 over 2 times A squared. So here we will get that, according to equation number 2, (36) equals to square root of 3 square is 3, 2 square is 4 times A squared. So this expression equals to 3/4 A squared plus 5 squared is 25 over 2 square is 4 times A squared. So in conclusion, according to equation number 2, we got that 36 equals to 3/4 times A squared plus 25/4 times A squared. That is to say, according to equation number 2, we will get that 36 equals to 3/4 plus 25/4 is 28/4 times A squared. So here we will get that 36 equals to 28 over 4 is 7, so it is 7A squared. We divide this equation number 2 by 7, and we get that according to equation number 2, A squared equals to 36 over 7. Okay. Here we take the root of this equation number 2, and we find out that according to equation number 2, A equals to the square root of 36, that is 6, over square root of 7. Okay. So, in the next step, I will present to you a new rule, that is rule number 3, that is related to angle bisector in a triangle. So this is rule number 3. According to rule number 3, if we have triangle ABC, that could be any triangle. In triangle ABC, we have triangle bisector AD. This is triangle ABC. We have here the angle bisector AD. I write down that AD is the angle bisector. So according to rule number 3, we'll get that AD square equals to AB times AC minus BD times DC. I repeat again, according to rule number 3, if you have triangle ABC, that could be any triangle, and you have the angle bisector AD, the following equation is true, that AD square equals to AB times AC times BD times BD minus AB times AC minus BD times DC. Again, AD square equals to AB times AC minus BD times DC. Okay, so we can implement rule number 3 in triangle ABC. Why? Because in triangle ABC we have the angle bisector AD, so I'll copy the triangle ABC in a new page, and we'll implement the angle rule number 3 in triangle ABC. Here, side BC equals to 2 plus 4, that is 6. So actually, this is triangle ABC that I copied from the original drawing. AB equals to A units, AC equals to 2A units, and BC equals to 6 units, and angle BC equals to 120 degrees. So according to rule number 3, we'll get that. So here we have also the angle bisector AD, of course. This is the angle bisector AD. And the angle bisector AD, BD equals to 2 units, and DC equals to 4 units. And according to rule number 3, we will get that AD square, AD equals to X according to what is given as the question. So this will be question number 3, AD square equals to AB times AC minus BD times DC. Okay. AD equals to X, so AD square is X square. That is equal to AB. AB is A, according to what is given as the question, times AC. AC is 2A, also according to what is given as the question, minus BD is 2, times DC is 4. So according to the question number 3, we get that X square equals to A times 2A is 2A square, minus 2 times 4 is minus 8. So actually, here x squared, according to equation number 3, x squared equals to 2 times a squared. We already found out that a squared equals to 36 over 7, so we'll substitute a squared by 36 over 7 minus 8. Here 2 times 36 is 72. So we get that according to equation number 3, x squared equals to 72 over 7. We'll multiply minus 8 by 7 and then we'll divide it by 7 in order to have a common factor with this expression. So minus 8 times 7 is minus 56 over 7. So here x squared equals to 72 minus 56 is 16 over 7. So in conclusion, we found out that x squared equals to 16 over 7. We take out of this equation and we get that x equals to square root of 16, that is 4 over square root of 7. So we actually found out that x equals to 4 over square root of 7 units, so in terms of numbers, is equal to 1.51 units. Okay. Here AD is equal to x equals to either 4.4 over 7 square root of 7, 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. We finish with the first method. In the next step I will present to you how to find out the length of side AD that is equal to x according to the second method. Okay. In the second method, we define angle ADB as theta. If angle ADB equals to theta, then angle ADC must be equal to 180 degrees minus theta, because of the fact that BC is one side of triangle ABC, therefore it is absolutely a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if you look on the upper side of the straight line BC at point D, then the sum of the angles here must be equal to 180 degrees. So if this angle is theta, this angle must be equal to 180 degrees minus theta, because theta plus 180 degrees minus theta equals to 180 degrees, exactly according to the rule that I mentioned. Okay, so in the first step I will present to you a new law, that is the law of sines. The law of sines is for an A triangle. So actually, if we have triangle ABC, that could be any triangle. This is triangle ABC. The length of side BC is A units. The length of side AB is equal to C units. And the length of side AC equals to B units. Okay. So according to the law of sines, we get that A over sine A, here capital A is the side of angle BAC, this angle. It is equal to B over sine B. Capital B equals to this angle, the size of angle ABC, and it is equal to C over sine C. Here, capital C equals to angle ACB, this angle. Okay? So in any triangle, A over sine A equals to B over sine B equals to C over sine C. So we'll implement the law of sines in our drawing in triangle ABD. In triangle ABD, according to the law of sines, we will get that A over sinus theta equals to 2 over sinus 60 degrees. In the next step, we will implement the law of sines in the adjacent triangle ADC. In triangle ADC, two A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. According to this trigonometric identity, we can substitute sinus 180 degrees minus theta in the equation number 2 by sinus theta. We do it now and we get that according to equation number 2, A over sinus theta equals to DC over sinus 60 degrees. So in the equation number 2 we have the expression A over sinus theta, but according to equation number 1, A over sinus theta equals to 2 over sinus 60 degrees, so we can substitute A over sinus theta in equation number 2 by 2 over sinus 60 degrees. We'll do it now, and we'll get that 2 times A over sinus theta, and A over sinus theta equals to 2 over sinus 60 degrees according to equation number 1. And it is equal to DC over sinus 60 degrees. So here we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. What is left from equation number 2 after we cancelled sinus 60 degrees? What is left is actually here we have in this side of the equation number 2, we left with 2 times 2 that is equal to DC. That is to say, according to equation number 2, DC equals to 2 times 2 is 4. So if 100, DC equals to 4 units. We can write here that DC equals to 4 units. Exactly as we write in the first method. As a result, in the next step I will present to you the law of cosines, and we will implement the law of cosines in the big triangle ABC. So actually, if we have triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. Side AB of triangle ABC equals to A unit in its length. Side AC equals to B units in its length. And side BC equals to C units in its length. Then, according to the law of cosines, we get that cosine theta, this is angle theta, equals to A square plus B square minus C square over 2 times A times B. I repeat again, according to the law of cosines, in any triangle, triangle ABC could be any triangle. Here, cosine theta equals to A square plus B square minus C square over 2 times A times B. So we can implement the law of cosines. This is the law of cosines. We'll implement the law of cosines in triangle ABC. So I will copy triangle ABC in this page, and we will implement the law of cosines in this triangle ABC. This is triangle ABC. This triangle equals to 60 degrees plus 60 degrees is 120 degrees. Side AB equals to A according to what is given as the question. Side AC equals to 2A according to what is given as the question. And we also know that BC equals to 2 plus 4, that is 6. Okay? So, according to the law of cosines, we get that cosine 120 degrees equals to A square is AB squared, that is A square. AB equals to A, so it is A square, plus B square. B square is AC squared, that is 2A squared. 2A squared is 4A squared, minus C squared. C squared is BC squared, that is 6 squared. 6 squared is 36 over 2 times A times AC, that is 2A. So this is equation number 3. Moving to equation number 3. Cosine 180 degrees, 120 degrees is minus 1/2. So minus 1/2 equals to A square plus 4A square is 5A square minus 36 over 2a times 2a. Here we have 2 on both sides of the equation, so 2 will get cancelled. We will cross multiply this equation, equation number 3, and we'll get that according to equation number 3. Minus 2 times a squared equals to 5a squared minus 36. So here we will add 2a squared and also 36 simultaneously to this equation, equation number 3, and we will get that 5a squared plus 2a squared is 7a squared. That is equal to 36. Here we will divide this equation, equation number 3, by 7, and we get it according to equation number 3, a squared equals to 36 over 7. Here we will take a root out of this equation, equation number 3, and we will get that according to equation number 3, a equals to the square root of 36 is 6 over square root of 7. Found out the value of a. So here in the next step I will present to you a new formula to calculate the area of any triangle. So here if we have a triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. We know that side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length. Then the area of this triangle, triangle ABC, it will be equal to A times B times sinus theta over 2. So the area of any triangle, triangle ABC, can be always calculated according to this formula. It will be equal to A times B times sinus theta over 2. We'll use this formula in order to find out the area of triangles ABC, triangle ABD, and triangle ADC. From the drawing it is very easy to see that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Okay? Triangle ABC consists of two triangles, triangle ABD and triangle ADC. The sum of the areas of the two small triangles equals to the area of the big triangle, that is actually triangle ABC. So I'll write it down. From the drawing we can see that the area of triangle ABC is equal to the area of triangle ABD plus the area of triangle ADC. Okay? So according to the new formula for calculate the area of any triangle, we get that the area of triangle ABC will be equal to A times 2A times sinus 120 degrees over 2. Okay, this is the area of triangle ABC. In the area of triangle ABD, according to the new formula, it will be equal to A times X times sine of 60 degrees over 2. And the area of triangle ADC, the area of this triangle ADC will be equal to X times 2A times sine of 60 degrees over 2. Okay, so here we have 2 on both sides of the equation, so 2 will get cancelled. And we also know that sinus 20 degrees equals to sinus 60 degrees. So sinus 60 degrees also will get cancelled. And you have A on both sides of this equation. So A will also get cancelled. What is left from this equation after we cancel all the variables? Here on this side of the equation, what is left is only 2A, and this is equal to X plus 2X. So we found out that 2A equals 2X plus 2X, that is to say 2A equals to X plus 2X, that is 3X. We divide this equation by 3 and we get that X equals to 2 over 3A. We have already found out that A equals to 6 over square root of 7 units. So we substitute A by 6 over square root of 7 units. Here we have 6 over 3 is 2. So it is 2 times 2 over square root of 7 units. 2 times 2 is 4. So in conclusion we found out that the length of line segment X, it is equal to, here, the length of line segment X, it is equal to AD, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay? So, in the next step, we'll summarize the lecture. We'll start with the first question. So we have here the square ABCD. Inside square ABCD, we have this circle. The radius of this circle is equal to 2 units. Line segment D equals to 1 unit, and we want to find out the side length of square ABCD. That is to say, the length of one side of square ABCD. Okay, so first of all, we define the center of this circle as point O, and from point O we join points O and M together by a straight line. OM, line segment OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is the point of the circle itself. So the radius of this circle R equals to 2 units. So the radius of this circle OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So if AD is perpendicular to MO, that is to say this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Here we join points O and L together by a straight line. ON is the radius of this circle for the same reasons. It starts from the center of the circle and ends at point L, that is the point of the circle itself. So here the radius OL is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO, that is to say this angle equals to 90 degrees, and this angle will also equal to 90 degrees. And we also know that all the angles inside a square are right angles, that is to say angle DAB, this angle equals to 90 degrees. So in quadrilateral MOAL we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract the 270 degrees from this equation and found out that the missing angle MOL equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this angle MOL equals to 90 degrees. So actually we found out that all the angles inside quadrilateral MOAL they are equal to 90 degrees. They are all right angles. Therefore quadrilateral MOAL must be at least a rectangle, so we relate to quadrilateral MOAL as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle MOAL, MO must be equal to AL. MO must be equal to AL, but MO equals to 2 units. We already found out that MO equals to 2 units. So we can write here that MO equals to 2 units. And from this equation, 2 equals to MO equals to AL, we derive that AL is also equals to 2 units. Here, AL is also equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we derive that MA equals to OL. MA equals to OL. But here OL equals to 2 units. We already found out that OL equals to 2 units. So we can write here that OL equals to 2 units, and from this equation 2 equals to OL equals to MA, we derive that MA is also equals to 2 units. Okay, MA is also equals to 2 units. So here we can write that MA equals to 2 units. So actually we found out that the quadrilateral MOAL is not a rectangle but a square. Quadrilateral MOAL is a square. Then I presented to you rule number 2 that the lengths of 2 tangents from a common external point to a circle are equal. So if we focus on the common external point E here, from the common external point E, we have 2 tangents to this circle. The first tangent is tangent EM, and the second tangent is tangent EZ. And according to rule number 2, EM equals to EZ. EM equals to EZ according to rule number 2. What is the length of EM? From the drawing, it is very easy to see that the length of line segment EM or tangent EM, it will be equal to DA minus DE minus MA. Again, DA minus DE minus MA equals to EM. Okay, EM equals to DA minus DE minus AM. And we defined the side length of square ABCD as X. So EM equals to DA equals to DE equals to X, and DA equals to AB equals to BC equals to CD equals to X. And then the length of lines, the length of tangent EM will be equal to AD, that is X, minus DE, that is 1 according to what is given as the question, minus AM or MA, that is 2 units according to what we have already found out. So EM equals to X minus 1 minus 2, that is to say EM equals to X minus 3. So we found out that EM equals to X minus 3. But according to rule number 2, EM equals to EZ from one side, but from the other side we just right now found out that EM is also equals to X minus 3. So we can write here that EM equals to X minus 3, and from this equation X minus 3 equals to EM equals to EZ, we derive that Ez is also equal to x minus 3. Here Ez is also equal to x minus 3. In the next step we focus on the common external point, point B. Here the common external point, point B. From the common external point, point B, we have two tangents to this circle. The first tangent is tangent BL and the second tangent is tangent BZ, and according to rule number 2 they must be equal to each other. So BL equals to BZ according to rule number 2. Okay? At point B, BL equals to BZ according to rule number 2. What is the length of line segment BL? It's very easy to see that the length of line segment BL it is equal to AB minus AL. Again, AB minus AL equals to BL. BL equals to AB minus AL. AB equals to X according to our definition, and AL equals to 2 units according to what we have already found out. So in conclusion, we found out that BL equals to X minus 2. Here, BL equals to X minus 2. But we have already found out that according to rule number 2, BL equals to BZ, and we just right now found out that BL equals to X minus 2. So here BL equals to X minus 2. So from this equation, X minus 2 equals to BL equals to BZ, we derive that BZ is also equals to X minus 2. Here BZ is also equals to X minus 2. Then we found out the length of line segment EA. What is the length of line segment EA? From the drawing it is very easy to see that the length of line segment EA equals to DA minus DE. Again, DA minus DA equals to EA. Here, A equals to DA minus DE. A equals to X according to our definition, and D equals to 1 according to what is given as the question. So in conclusion, we found out that EA equals to X minus 1. AB equals to X. AB equals to X. So actually, we copied the right triangle EAB in a new page and we implemented the Pythagoras theorem on this right triangle, triangle EAB. The hypotenuse DE equals to X minus 3 plus X minus 2. Here the hypotenuse EB equals to X minus 3 plus X minus 2. So X minus 3 plus X minus 2 is X plus X is 2X, and minus 3 plus minus 2 is minus 5. So in conclusion, we found out that hypotenuse EB equals to 2X minus 5. So we implemented the Pythagoras theorem on this right triangle, triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, EB square equals to EA square plus AB square. Here, EB square equals to EA square plus AB square. EB equals to 2X minus 5. EA equals to X minus 1, and AB equals to X. Okay, we square this sides, because here it is with square. And we got this equation. We open the brackets on both sides of the equation according to the algebraic identity that A minus B square equals to A square plus B square minus 2 times AB. So here 2X minus 5 square equals to 2x squared, that is actually 4x squared, plus 5 squared, that is 25, minus 2 times 2x times 5, 2 times 2 is 4, and 4 times 5 is 20, so it is minus 20x. That is equal to x minus 1 square. X minus 1 square equals to x squared, plus 1 squared, it is 1, minus 2x, plus x squared. So in this side of the equation we have 4x squared minus 20x plus 25, and the other side of the equation we have x squared plus x squared is 2x squared, 2x squared minus 2x plus 1. We subtracted 2x squared from this equation, equation number 1. So here 4x squared minus 2x squared is 2x squared. And we subtracted also, we added 2x to this equation, equation number 1. 2x minus 2x is 0, and minus 20x plus 2x is minus 18x. and we have 25 and 1. So here we subtracted 1 from this equation number 1. 1 minus 1 is 1, and 25 minus 1 is 24. So in conclusion, we got that according to equation number 1, 2x squared minus 18x plus 24 equals to 0. We divided this equation number 1 by 2, and we got that x squared minus 9x plus 12 equals to 0. The coefficient A here is equal to 1, the coefficient B equals to minus 9, and the coefficient C equals to 12, and the general formula for solving out a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here, in our specific quadratic equation, x equals to minus b, b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared, b equals to minus 9, so b squared is minus 9 squared, that is 81, minus 4 times a is 1, times c, that is 12. So it is minus 4 times 12 over 2a. A is 1, so 2 times 1 is 2. X equals to 9 plus minus square root of 81 minus 4 times 12 is minus 4 times 12 is minus 48 over 2. So x equals to 9 plus minus 81 minus 48 is 33. So inside the what we left only with 33 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. So here 9 minus square root of 33 over 2 is 1.62. So we found out that x equals to 1.62. So x is the side length of square ABCD, and according to the first solution, x, that is to say AB, that is equal to x, it is equal to 1.62 units. So here x equals to 1.62 units. But it is impossible that x equals to 1.62 units, because here x, that is equal to AB, it is bigger than AL. X is bigger than AL, so x must be bigger than AL. X must be bigger than AL. That is to say, x must be bigger than AL, that is equal to 2. That is to say, x must be bigger than 2 units. X must be bigger than 2 units, and 1.62 is less than 10 units. That is to say, this solution is incorrect solution. So we will abandon this solution and we'll cancel the solution, and we will focus on the second solution. The second solution for x is x equals to 9 plus square root of 33 over 2. That is to say, x equals to 7.37 units. Okay, that is the answer to the first question, that the side length of one side of square ABCD equals to 7.37 units. We finish with the first question. Then I presented to you how to find out, they presented to you how to solve the second question in two different methods. In the drawing we have triangle ABC, side BD equals to 2 units, AB equals to A, AC equals to 2A, angle BAD equals to 60 degrees, angle DAC equals to 60 degrees, and AD equals to X, and we want to find out the value of the length of side AD that is equal to X. Okay, so in the first step, I presented to you the angle-bisector theorem. The angle-bisector theorem is true in any triangle. According to angle-bisector theorem, here we have triangle ABC that could be any triangle. here AD is the angle bisector. Why AD is the angle bisector? Because of the fact that it divides angle BAC into two halves. Each half equals to theta. So in triangle ABC we have the angle bisector AD, therefore we can implement the angle bisector theorem in this triangle, triangle ABC, that could be any triangle. According to angle bisector theorem, we will get that AB over AC equals to DB over DC. Again, AB over AC equals to DB over DC. So we can implement the angle bisector theorem in triangle ABC. Why? Because triangle ABC, this triangle ABC, it has side AD that is the angle bisector. AD divides angle BAC into two halves, each half equals to 60 degrees, therefore AD is defined as angle bisector, therefore we can implement the angle bisector theorem in triangle ABC. We did it and we got that according to angle bisector theorem, we get that AB over AC equals to BD over DC. AB over AC equals to BD over DC. AB equals to A, AC equals to 2A, BD equals to 2, and DC equals to DC. This is the missing line segment. A over A is 1, so A will get cancelled. And in this side of equation number 1, we have 1/2 that is equal to 2 over DC. Because multiply this equation number 1, and found out that DC equals to 2 times 2. 2 times 2 is 4, so we found out that DC, the missing line segment DC equals to 4 units. Then we did the construction. We extended side AC of triangle ABC by a straight line. And from point B, we raised perpendicular to the extended CA. So this angle AEB equals to 90 degrees according to our construction. We define the touching point of the extended CA and the perpendicular from point B as E. Okay, so here we extended the straight line CA by straight line. The result is CE. When you extend a straight line by straight line, the result must be a straight line. Therefore, CE is a straight line. CE or EC is a straight line. And we have the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. Here, if you focus on the lower side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees. So which angles we have on the lower side of EC at point A? We have here 60 degrees plus 60 degrees plus angle BAE. In total, the sum of those three angles must be equal to 180 degrees. So 60 degrees plus 60 degrees plus the sine of angle BAE, in total they must be equal to 180 degrees according to the rule that I mentioned. 60 degrees plus 60 degrees is 120 degrees, so 120 degrees plus angle BAE equals to 180 degrees. We subtracted 120 degrees from this equation and found out that the missing angle BAE, this angle BAE equals to 60 degrees. Then we focused on the green triangle EAB. On the green triangle EAB, cosine 60 degrees equals to AE over AB. Cosine 60 degrees equals to EA over BA. So cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and that is equal to EA over BA. BA equals to A, so we substitute BA by A. So in conclusion, we found out that 1/2 equals to EA over A. We multiplied this equation by A, and we found out that EA equals to A over 2. Here EA equals to A over 2. Then here sine of 60 degrees equals to BE over AB. The sum green triangle sine of 60 degrees equals to EB over EA. Here sine of 60 degrees. Sine of 60 degrees it is actually equals to EB over AB. Okay, here it is actually here sine of 60 degrees equals to EB over AB. Okay, it is equal to EB over AB. So sinus 60 degrees equals to EB over AB. AB is A, so we substitute AB by A. So in conclusion, we found out that sinus 60 degrees equals to EB over A, and sinus 60 degrees is square root of 3 over 2. So we substituted sinus 60 degrees by square root of 3 over 2. And we got that square root of 3 over 2 equals to EB over A. We multiplied this equation by A, and we found out that EB equals to square root of 3 over 2 times A. So here EB equals to square root of 3 over 2 times A. Then we implemented the Pythagoras theorem on the big triangle ABC. So I copied triangle ABC in this page, and we implemented the Pythagoras theorem on this triangle ABC. Here side EC equals to 2a plus a over 2. 2a plus a over 2 is 2.5a. 2.5a, and 2.5a is 5 over 2a. We have already found out that EB equals to square root of 3 over 2 times a, and the hypotenuse BC equals to 2 plus 4, that is 6. So in triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BC square equals to EB square plus EC square. BC equals to 6, so BC square is 36. And EB square, here EB equals to square root of 3 over 2 times A, so EB square is square root of 3 over 2 times A square, plus EC square, that is 5 over 2A square. So here we got that 36 equals to, this expression squared is 3 quarters times A square, and here 5 over 2 times A square is 25 quarters A square. 3 quarters plus 25 quarters, 28 quarters times A square. 28 over 4 is 7. We divided this equation number 2 by 7, and found out that A square equals to 36 over 7. We took out of this equation number 2, and found out that A equals to 6 over square root of 7 units. So we found out the value of A. Then I presented to you rule number 3, and here we have triangle ABC that could be any triangle. AD is the angle bisector because it divides angle BAC into 2 halves, each half equals to theta. So in this triangle ABC we have the angle bisector AD, therefore we can implement rule number 3 here. According to rule number 3, AD square equals to AB times AC minus BD times DC. Again, AD square equals to AB times AC minus BD times DC. We implemented rule number 3 in triangle ABC. Why? Because in triangle ABC, this triangle ABC, we have the angle bisector AD. Angle bisector AD divides angle BAC into 2 halves, each half equals to 60 degrees. For that reason, you can implement the rule number 3 in triangle ABC. And according to rule number 3, we get that AD square equals to AB times AC minus BD times DC. AD square equals to AB times AC minus BD times DC. AD equals to x according to what is given as the question, so AD square is x square. AB equals to A, AC equals to 2A, DB equals to 2, DC equals to 4. So here x square equals to A times 2A is 2A square, and minus 2 times 4 is minus 8. So here x square equals to 2A square, but A square equals to 36 over 7, so we substituted A square by 36 over 7 minus 8. So here 2 times 36 is 72. Then we multiplied minus 8 by 7. Minus 8 times 7 is minus 56. And we got that x square equals to 72 minus 56, that is 16 over 7. So we found out that x square equals to 16 over 7. we took out of this equation and found out that x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. We finish with the first method. Then I presented to you how to find out the length of side AD that is equal to x according to the second method. In the second method, we defined angle ADC as theta, therefore angle ADB is theta, therefore angle ADC must be equal to 180 degrees minus theta. Then I presented to you the law of sines. In any triangle ABC would be any triangle, if A over sinus A equals to B over sinus B equals to C over sinus C. Capital A, capital B, and capital C are the sizes of angles BAC, angle ABC, and angle BCA correspondingly. So we implemented the law of sines in triangle ABD. According to the law of sines, we get here that in this triangle ABD, A over sinus theta equals to 2 over sinus 60 degrees. Again, A over sinus theta equals to 2 over sinus 60 degrees. Here, A over sinus theta equals to 2 over sinus 60 degrees. Then we implemented the law of sines in this triangle, triangle ADC. This triangle, triangle ADC, we get that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. Again, 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. 2 over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta, so we can substitute sinus 180 degrees minus theta by sinus theta. We did it, and we got that according to equation number 2, 2A over sinus theta equals to DC over sinus 60 degrees. Here we have A over sinus theta in equation number 2, but according to equation number 1, A over sinus theta equals to 2 over sinus 60 degrees, so we can substitute A over sinus theta in equation number 2 by 2 over sinus 60 degrees. We did it, and we got that here 2, and here A over sinus theta equals to 2 over sinus 60 degrees, according to equation number 1, and it is equal to DC over sinus 60 degrees. Here we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. And what is left for equation number 2 after we cancelled sinus 60 degrees? What is left is that 2 times 2 equals to DC. That is to say, according to equation number 2, we found out that DC equals to 4 units. Here DC equals to 4 units. Then I presented to you the law of cosines that is true in any triangle. If we have this triangle, triangle ABC, the length of AB is A, the length of side AC is B, and the length of side BC is C. Here, angle BAC equals to theta, then cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. We implemented the law of cosines in triangle ABC, so I copy triangle ABC in this page, and we implemented the law of cosines in this triangle, triangle ABC. So in this triangle, triangle ABC, according to the law of cosines, we will get that cosine 120 degrees will be equal to AB squared, that is A squared, plus AC squared, that is 2A squared, and 2A squared is 4A squared, minus C squared. C squared is BC squared, and BC squared is BC is 6, so BC squared is 6 squared, that is 36, so this minus 36 over 2 times AB, 2 times AB, 2 times it is 2 times A times 2A. Okay, 2 times A times 2A. Cosine 180 degrees equals to minus 1 half. Here A squared plus 4A squared is 5A squared minus 36 over 2A times 2A. Here we have 2 on both sides of the equation, so 2 will get cancelled. Then because multiply this equation, equation number 3, and we got that according to equation number 3, minus 2A squared equals to 5A squared minus 36. We added 2A squared and also 36 simultaneously to equation number 3, and found out that 5a squared plus 2a squared is 7a squared. That is equal to 36. We divided this equation number 3 by 7, and we found out that a squared equals to 36 over 7. We took out of this equation number 3, and we found out that a equals to the square root of 36 is 6. So in conclusion, we found out that a equals to 6 over square root of 7. Then I presented to you a new rule to calculate the area of any triangle. So this is triangle ABC that could be any triangle. Side AB equals to A units in its length, side AC equals to B units in its length, and angle BAC equals to theta. Then according to the new rule, the area of this triangle ABC that could be any triangle will be equal to A times B times sinus theta over 2. Okay, the area of this triangle equals to A times B times sinus theta over 2. So we implemented the law of the new rule in our drawing. Here, the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Okay? The area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. The area of triangle ABC, according to the new formula, it will be equal to A times 2A, to A squared, A times 2A times sinus 120 degrees over 2. Okay, it is equal to A times 2A times sinus 120 degrees over 2, and the area of triangle ADB equals to A times X times sinus 60 degrees over 2. Is equal to A times X times sinus 60 degrees over 2, and the area of this triangle ADC equals to X times 2A times sinus 60 degrees over 2. It is equal to X times 2A times sinus 60 degrees over 2. Here we have 2 on both sides of the equation, so 2 will get cancelled. And we know that sinus 120 degrees equals to sinus 60 degrees, so sinus 60 degrees will also get cancelled. And we have A on both sides of the equation, so A will also get cancelled, and we left only with 2A that is equal to X plus 2X. So 2A equals to X plus 2X is 3X. So 2A equals to 3X. We divided this equation by 3, and we found out that X equals to 2 over 3 times A. We substituted A by 6 over square root of 7 units, and we found out that X equals to either 6 over 3 is 2, so we found out that X equals to 2 times 2 over square root of 7. 2 times 2 is 4. So in conclusion, we found out that the area, the length of side AD that is equal to X, it is equal to 4 over square root of 7 units. So in terms of numbers, it is equal to 1.51 units. Again, the area, the length of side AD that is equal to X, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. I repeat on the area, how we've calculated the area of triangle ABC according to the new formula. It is equal to A times 2A times sinus 120 degrees over 2. It is A times 2A times sinus 120 degrees over 2. And the area of triangle ABD equals to A times X times sinus 60 degrees over 2, and the area of triangle ADC equals to X times 2A times sinus 60 degrees over 2. So in both methods we arrive to the same result for the value of AD. It is equal to either X equals to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. Okay, thank you very much.